So let's talk about Antarctica. We're going to dive into the future of the world's largest ice sheet, and it's all based on a really groundbreaking study. It turns out Antarctica is facing two possible futures, two completely different paths. And the choice between them? Well, as we're about to see, that really comes down to us. First, you just have to wrap your head around the sheer scale of this place. Antarctica isn't just some big chunk of ice. I mean, we're talking about a whole continent that holds 90% of the world's ice. If it all melted, and I mean all of it, global sea levels would shoot up by nearly 60 meters. That's almost 200 feet. It is, without a doubt, the single biggest potential source of future sea level rise. Okay, but here's the twist, and it's a big one. What if I told you that a warming planet could actually, somehow, make this massive ice sheet grow? Yeah, it sounds completely backward, I know. But the science behind it is pretty straightforward. See, as the air warms up, it can hold more moisture. More moisture in the air means, you guessed it, more snow over this incredibly vast and cold continent. And that process literally pulls water out of the ocean and locks it up on the ice sheet. So what this does is set up this massive, titanic struggle for the future of the ice. It really is a tale of two opposing forces, a constant battle between what adds ice and what takes it away. Now, scientists have a name for this battle. It's called surface mass balance, or SMB for short. The easiest way to think about it is like a bank account for the ice sheet. Every time it snows, that's a deposit. And anytime ice melts and the water runs off into the ocean, that's a withdrawal. The balance between those two is what tells us if the ice sheet's surface is getting thicker or thinner. And get this, for most of the 20th century, the deposit side of this tug-of-war was actually winning. There was so much extra snowfall that Antarctica's surface actually lowered global sea levels by a little bit. But as you can imagine, that delicate balance is now seriously under threat. So, what's the big threat? The game changer that can tip this balance over the edge? Well, it's a process called hydrofracturing, and this is where simple, ordinary meltwater turns into a powerful weapon against the ice itself. You see, a little bit of melting on the surface isn't really the issue. The top layers of snow act like a giant sponge, and they can soak up some of that water, which then just refreezes. The real danger starts when the melting gets so intense that the sponge is just completely saturated. That's when liquid water starts to form these huge pools on the surface. So what happens next is this incredible chain reaction. That water pooled on top is actually heavier than the ice it's sitting on. It finds its way into any little crack or crevasse it can, and then the sheer weight of all that water acts like a wedge, forcing that crack deeper and deeper until it can literally shatter a whole ice shelf from the top down. And look, this isn't some far-off theory. We've seen this happen with our own eyes. The shocking and super fast collapse of the Larsen A ice shelf in '95, and then the even bigger Larsen B in 2002. Both of them had widespread meltwater pooling on the surface right before they disintegrated. It was the smoking gun for hydrofracturing. And that brings us right to the heart of this 2025 study. Scientists took everything we know about this process and modeled two completely different futures for Antarctica. And the difference between them? It's a story written entirely by the choices we make about global emissions. The study basically looked at two roads. On one road, we have a low-emissions world, where we take really aggressive climate action. On the other, well, that's the high-emissions road, which is basically business as usual, with a heavy reliance on fossil fuels. As you're about to see, the destinations are worlds apart. In that low-emissions future, the news is actually pretty good, all things considered. That tug-of-war between snowfall and melting stays pretty balanced. Snow keeps piling up, mostly offsetting the melt, and the vast majority of those crucial protective ice shelves stay safe and stable. We avoid the worst-case scenario. But if we stay on that high-emissions path, oh boy, the story is completely different. The study found that by the year 2150, every single one of Antarctica's 56 major ice shelves could become vulnerable to that kind of catastrophic collapse we saw at Larsen B. Every single one. And in that high-emissions world, there's this really cruel twist. For a little while, all that extra snow actually helps protect the ice. But that benefit, it peaks around the 2040s. After that, the whole thing starts to flip. By 2120, the meltwater really starts to win the tug-of-war. And by the year 2200, the dynamic has completely reversed. Antarctica's surface goes from being a place that stores ocean water to one that's actively dumping more water in. And this is where the numbers just tell the whole story. With low emissions, Antarctica's surface keeps helping us out, lowering sea levels by up to 10 centimeters. But with high emissions, the outcome becomes wildly unpredictable. I mean, look at that range. It could lower sea levels by 33 centimeters, or it could add 6 centimeters. That potential switch from a huge net positive to a net negative, that's the tipping point we are risking.
Okay, so let's zoom out. Let's bring this all the way back from a frozen continent at the bottom of the world. Why does the fate of these ice shelves matter so much to you, to me, to coastlines everywhere?
It's a great question, right? An ice shelf is already floating in the ocean. So when it breaks up, it's kind of like an ice cube melting in your drink. The water level doesn't really change. So what's the big deal? The secret is what the ice shelves are doing while they're just sitting there. You have to think of them as the gatekeepers of Antarctica. They're these huge, floating extensions of the land ice. And they act like a giant cork in a bottle, physically holding back the massive glaciers on the continent. So when hydrofracturing comes along and shatters one of these guardians, poof, the cork is gone. The land-based glaciers behind it, the ice that is not already floating, are suddenly uncorked. They speed up, sometimes dramatically, and start dumping trillions of tons of ice into the ocean way faster than before. That's what causes rapid sea level rise all over the world. All right, so let's boil this all down. What are the big things to remember? First, Antarctica's future is a delicate tug of war between snow piling up and meltwater running off. Second, that balance can be totally wrecked by hydrofracturing, which destroys the ice shelves that act as guardians. And third, the single most important factor that decides which way this goes is our emissions path. And this is why this kind of science is so incredibly important. It isn't telling us our fortune. It's not a prediction of a future that's set in stone. It's presenting us with a choice between futures. The ending to the story, it hasn't been written yet. So here we are. This study lays out two possible futures with incredible clarity. One, a future where Antarctica remains a relatively stable, frozen giant. And another, where it begins a catastrophic process of collapse. The science shows us what's possible. The choice of which one becomes our reality, well, that's on us.